Oh, we got the Zoom.
Oh, he's waving for Zoom.
Yeah.
Okay, the other piece of business, this just happened this morning, early this morning. Sam's Deli had a big old fire, and it's no longer Sam's Deli, it's Sam's Smoke Shop. I would be surprised, frankly, if that thing reopens in a time span of 2 years. You know, everything's got to be upgraded to the current code standards, and there's a permit process and insurance settlements, and we'll see where it goes. So I'll pretty much guarantee you at our next board meeting, we're going to be thinking about how we're going to handle our Christmas event this year, and I can guarantee it's not going to be the same.
You just muted the audio from Phil.
We've augmented our abilities to handle our presentations. We've got a 2-camera arrangement, and we have somebody that lets people in and out of the Zoom meeting, and we've got some different audio stuff that we can mix. Are you here for the ham club meeting? What's your name?
K630.
Welcome.
Well,
Somebody put ARRL on your shirt. Did you know that?
Did they? I know it's on there.
yeah.
Like that, so.
And there's a sign-in.
I thought he was trying to show us his chest. I don't know when.
Just work out that way, I suppose.
So anyway, welcome. I'm Phil by KD6R. We had a NanoVNA clinic. Actually, we have 2 of them. We ended up with 8 attendees at each, which was a sold out session for both events. We had, and it ended up being broken into 2 parts. The first part covered what you call port 0. It's measurements of reflection. Everything in the RF world revolves around reflection. Standing wave ratio, guess what that's all about? Reflection. And so these instruments, and we're going to go through this tonight, these instruments take advantage of those reflection characteristics, and that tells us a lot about the antenna, impedances. So in any event, the final session, which is the second half, is this coming Thursday. For those who went to the second introduction, and it's at the Fair Oaks Library, Fair Oaks Boulevard, and right off of Madison. So be there, be square. Starts at 6. Another note, and this one kind of sticks in my craw just a little tiny bit. In this year's elections, no one volunteered for the office of president, and no one was recommended or nominated for the office of president, which is why I nominated myself for vice president, hoping to find somebody to do the important stuff. And I think I should explain myself here just briefly. My love of this hobby revolves around figuring out how NanoVNAs work and antennas work and RF amplifiers work and oscillators and mixers. I like playing with stuff. I like building that stuff. I like digging into the nuts and bolts of that stuff. I'm not a 2-meter guy. I'm not a 440 guy. I play just a little tiny bit VHF stuff. I love antennas, but you guys need somebody who's more representative of the breadth of this hobby. People are into emergency communications. People are into the 2-meter stuff. People that are into the amateur television. You need somebody to represent those interests. I'm not the guy, but I'll do what I can to help in the interim. Elmer volunteers, which is something that's been going on in our club for years. We've got this note in our bulletin and on our website about how we're Elmer friendly. The problem is we really aren't that aggressive with our Elmer program. And I think, by the way, anybody here Can you tell me what you think the very first question asked of the brand new? The very first thing he asked to have help with?
What should I buy?
How much does it cost?
How do I get over the fear of the microphone?
Well, I actually volunteer an answer, and the answer is, how do I program my BOFA?
Yeah.
That is the one I've heard so many times, and it's the one that stumps the newbie. And so in my newsletter article, I talked about how we need a couple of people in the club to volunteer to be Elmers for programming the Bofang with a new hand. And let me explain to you what I have in mind. You get a call from Pete, who's a brand new licensed hand. He needs help programming it. Say, Pete, how about we meet down at Starbucks Saturday morning at 9:30, and I'll show you how to do that. Literally, that's all you got to do. Spend a few minutes with him, punch a few keys, get him started. You have a friend for life, and he knows that the community loves him. And I want to see some people step up to do that. That's the nature of our hobby. This is a social organization that deals with technical issues. We've all been down that path. We all know what it's like to not know anyone and to not know how to deal something. Haven't we all been down that path? So we need some guys to step forward. And we had one. But I would like to see more of them. And there's some other things where I think we can move forward on this. I think somebody to help somebody get started on FT8 would be a really good Elmer kind of guy. And there are others. But let's start with the first one, the one that you hear more often than anything else. How do I program my Bofang? Does that make sense? Is it too much to ask?
So,
Yes.
could you move closer to the camera because we need for the microphone?
Oh, is that better?
We're checking with the Zoom people.
Oh.
Keep it a little bit closer.
Oh my gosh. I'm gonna break the camera. So in any event, you know what I'm trying to do. One other thing that we need a little help with. Now, I explained to you how we're meeting in the library. The reason we're meeting at the libraries is because our old meeting site, which is the Sacramento area sewer district headquarters, or actually it's the remote headquarters, right off of Greenback, or Madison, I should say. They shut down their meeting room due to COVID concerns, and they've not reopened it. But I would like to find us a more permanent facility than what we're currently doing. And if any of you have any ideas, they'd be appreciated, and we could follow up on them. So we've covered that.
So,
And at this point,
you're walking away.
Back up.
what are they gonna nail my feet to the damn floor?
We need an X like they do in production.
I don't like your damn camera.
Hey.
So I would like each of you to think about things you'd like to have presented at our meetings. At our board meeting, we sit down and try to brainstorm these things with very little input from our membership. So guess what you get? You get our recycled ideas instead of what you're really interested in. And you guys can do that. And by the way, on our website, we have this little place called Contacts. Have you seen that button on our website? So contacts, you type a little note in there and Carol finds them, and then she kind of distributes that stuff out. If there's something you're interested in, don't be shy. Let's get it on there, and we'll see what we can do to help you out. Is Jojo on?
Yeah.
Is he ready to do his presentation?
Let's see if he jumps on.
Yes.
He said yes.
Oh, good.
Thank you, Phil.
I'm going to get away from the camera so Jojo can make his presentation.
We're gonna have to get the sound. Where'd it go?
Can I share my screen?
Yeah, go ahead.
Thank
We're
you.
work- We're working on the sound as well.
Okay, well, good evening. This is Jojo, KN6HTD, presenting the February Treasurer and Membership Report.
We have to get-
I trimmed down the report to the things that the general membership will be concerned about. And these are real-time snapshots of what we have in our website as well as in our bank. So currently, we're counting the paid members for 2023, and it is 98. If you see your call sign here, then you are paid for this year. If not, please let me know, especially if you have paid, but I have not credited it yet. We have evergreen donors, David, Lawrence, and Sylvia. I saw Sylvia, thank you. And there are some perks to being evergreen donors. And just to remind everyone, these are all voluntary contributions. We will go to the balance in our bank, which as of this morning, it is 9,963.68. And membership payments are still coming in. And I have within 7 days to reflect them on our website as well as in our membership database. And you always receive my acknowledgement letter. And currently, we are thankful that we are able to invest in a better audio-visual equipment, and that is not cheap. So we're spending $1,100 for our investment on that, and we are using it now. So thank you for all those who worked on this. Thank you that we have a budget, and that will be deducted from this 9963.68. Other than that, that is all for my report, and thank you very much.
Jojo, how about membership? What's our membership stand at now?
The audio was poor. I can't hear it.
How does the membership stand?
How's the membership status?
How many members do we have?
Phil, on top of the list, top of the roster, you see that paid members.
How many members do we currently have?
Total.
Oh, let me open up the file, but
Around 180.
I did not include the total number of members, which includes 11 life members. And that's all there is to our membership after the paid members. Over 100.
Okay,
Okay, thank you.
good job, Jojo. Thank you.
Thank you too.
I'll get close to the camera. Is this better now?
No, I can't see it.
The police showed up.
They are.
Oh, that's our new member.
Highway patrol guy.
Yeah.
Kind of cold out there, isn't it?
Not too bad.
Not too bad.
Still about 50.
Would you introduce yourself and your call?
Mark, W6AE.
Ooh. Yes, I should know that. In any event, it's time for your website information.
Okay, first of all, I want to thank the club and the board for investing in this. We're still learning, so there's going to be some bumps in the road here with this presentation, but I'm going to try now, see how this works. Nope, that doesn't even feed. Okay. Well, it should be streaming. It's not doing it. Okay.
Carol got this new equipment late yesterday.
Yeah, we had a very short time to learn how to use this. So I'm afraid I can't, it's not projecting. It should be connecting here, but it's not. Let me just say that thanks again to the website design team who's working on this. I want to remind everyone that our nets are Wednesday, 8 p.m. Then we have our 2-meter net on 145.25 megahertz repeater with a negative offset and a PL 162.2. And we also can be joined on Echolink and also on All-Star. At 8:30 p.m., a 10-meter net is on our 28.420 megahertz upper sideband. And then at 9 p.m., we have our slow scan TV net on 441.30 megahertz repeater. And it also streams on our YouTube Live. Oh, yes, actually, we do have a kind of an unofficial roundtable net also now on Saturdays at 3 p.m. And that's on 7180 kilohertz lower sideband. Everybody's welcome to join us there. This is for just a friendly chat, and that's 3 p.m. on Saturdays. As far as the website activity for the month of December, we had a total of 1,440 page views during December. I'm sorry, not December. This should be January. Just January. The peak number of web page views was 112 on January 11th. 524 views were the home page. 84 views were of our DIY radio group page. The All-Star page had 70 views. Magnetic Loop Antenna Project page 62, and the membership page had 61 views. 39% of our visits were directed through Google, and 30% came direct through our n6na.org website URL. By region, most of our views came from California, 1,106, 29 were from Washington State, 20 from Oregon, and the others from other states and countries around the world. We currently have 395 subscribers on our YouTube channel. We had 446 views last month on our YouTube channel. We have 664 followers on our Facebook page, 145 followers on our Twitter page, and there are 32 members on our Discord chat group. And just a reminder, if you need to contact us at all, you can send an email to contact@n6na.org. And I hope we get a little smoother next time, but this is our first try.
And it's a fine try.
Thank you.
By the way, these two stepped right in to give it a whirl, and I think they're doing a fine job. Can we bring up the PowerPoint? Now, is this the Zoom camera?
This is Zoom camera, yes.
I gotta figure out where I gotta be here.
Okay, I'm going
You
to.
need to do share screen. Share the
Look at all that stuff.
Oh, okay.
Yeah.
Share screen. Ah, yeah, so much. Perfect. And then from beginning, I think is where we want to be. Cool. All right, so where am I supposed to be with this thing?
Right there,
Right there?
next to the camera, so we can.
Okay. I mentioned earlier that we had held a couple of clinics on this NanoVNA thing. And let's talk just a little bit about what a VNA stands for Vector Network Analyzer. And for years, the only place you could find one of those is when you went down and saw your friendly neighborhood Hewlett-Packard guy, and he showed you a price book that starts at over $10,000 for one of them. They were only used in engineering circles, RF engineering circles, pretty sophisticated stuff. So nowadays, the NanoVNA sells the low bucks, and it is incredible that allows you to figure out what's really going on with your antenna, in addition to a whole bunch of other things. So when we did this little clinic, It was a hands-on clinic. What you're going to see tonight is just the PowerPoints that go with the clinic that'll give you an idea of what was covered and how we approached it. Okay, so far so good? All right. Oops. Let's try that. So in order to do one of these antenna clinics, you needed antennas. And so I built an 80-meter dipole antenna there, and a 40-meter dipole antenna there, and a 20-meter dipole there, and a 17-meter dipole there. And we have some members of that class here. Did the dipoles work?
Yeah.
Worked fine. It
They're approved
looked
by the
exactly like an antenna would look,
They're
right?
approved by the HOA, right?
Approved by the HOA. So anyway, these things were set up so that this is where the inductor goes, and this is where a capacitor can go, and this is where a capacitor can go, and here's the pieces that you can plug into those holes. So you make a measurement of the antenna. What happened?
They're still working out their antennas here.
Oh, you make a measurement of the antenna, and then the labs were, okay, let's make this antenna work on a different frequency. So let's go through that process. Oh, we lost our,
Hang on.
See if that works.
oh, this is good. So I took one of these antennas and I made a measurement. Oops. Here's the SWR curve. That looks pretty damn good, doesn't it? The only problem is it's resonant at 6.9 something. That's okay. The whole clinic was to change the resonant point. But I made another measurement over here, and the difference is I put 20 foot of coax between the antenna and the measurement device. What's wrong? Looks weird, doesn't it? You know why?
Coax affects the signal.
I'm sorry,
Coax affects the,
but you had mentioned something.
You introduced reactance there as well.
Yes. A piece of coax is a transmission line, and transmission lines act as impedance transformers. So you take your brand new $500 antenna analyzer and you hook it to your antenna, you're going to get that. But if you put a piece of coax between your antenna and that $500 instrument, you get that. Now, the good news is the SWR on both of them will read the same. Okay, but the impedance of the antenna doesn't. And why did you buy an antenna analyzer? This is easy. Why did you buy an antenna analyzer? So you could fix your damn antenna, right?
yes.
But if you don't know what's wrong with your antenna, how are you going to fix it? You spent $500.
That's what you need to analyze.
They're all analyzers.
No, that's why you need to analyze the antenna.
Yes. But guess where you need to measure the antenna?
Not at the transceiver.
At the antenna. Because the transmission line is an impedance transformer. So here we go. I showed you the example of that 40-meter thing. Initial impedance was pretty close. A dipole has what nominal impedance generally? Halfway dipole. Somebody's going to say 72 ohms, right?
Yeah.
So this is pretty close, 76 ohms. And this plus.
Not you.
That's us.
The,
Testing it there. You got license.
okay, so anyhow, and it says that a plus reactance means it's inductive. It's a little bit long, okay? So it says it's just a tiny bit long. Then I had this 20 foot of coax. Now all of a sudden, instead of being 76 ohms, it's 35 ohms. And the antenna, guess what? Suddenly got short. So now you know why it is essential to do OSL at the calibration point. You know what OSL stands for? Open, short, low. And every vector network analyzer. And nowadays, those are all the antenna analyzers. Every one of them works exactly the same way. So if you're trying to figure out if your antenna is too long or too short or the wrong feed point, using a piece of coax between your fancy $500 machine and the antenna, you will drive yourself crazy and you will never get the right answer. And nobody likes that answer. By the way, a number of antenna analyzer manufacturers put a Bluetooth chip in their analyzer so that you can put the analyzer on the antenna and sit in your shack and read the information. The easier way to do it is you just do the open short low calibration on the end of the coax that you're going to attach to your antenna. That's the way it's done. Okay, so I told you that, and I told you that the SWR doesn't change. It stays the same because that's reflected energy. It's just the energy that's reflected, and that's why those numbers don't change. The impedance, however, does change. Okay, next slide. Says here in fine print. What happened to my clicker?
Well, let me advance it.
Here it goes.
Go back. So here's your NanoVNA. And this is a tiny one. This has got that little 2.8-inch screen. And this little stylus is what you use to set the parameters. Now, there's another way of doing it using some software. I'll get that. Next screen. So here's what comes up. If you take that little stylus and you click right down here, you're going to get this. So this is how you want the display to work, where markers are. Stimulus is the frequency you're measuring. This is a calibration thing. This is where you save what's been calibrated. And of course, you can close to the next screen. And once you get into one of those modes, you want to enter some numbers. So you click right down there, and here's the numbers. You just enter 7.15 M for megahertz or whatever it is. Okay, so far so good. Next screen. So here it is. Now here's display, marker, calibration, recall, close. You start that. Next screen. So let's say you selected one, then you tell it what trace you wish to use, what the format is. No, you went too far. The format is whether you wish it to be SWR or Smith chart or phase or return loss. I'm giving you all these numbers, and then you can also tell it what channel you want. There's 4 channels. And then you got some other options. What was that one? Can't read. Mode, yeah. Okay, next slide. And then each trace has a different color. So there's trace 0, 1, 2, and 3, and they end up being displayed on the screen. You select those, next screen. And once you get all that stuff over, here's the things you can measure. You can have a log magnitude scale. This is the phase, this is delay, Smith chart, SWR. There's some other options under more. Back. I can't read that one. Oh, this is the 4 channels. You can only display 4 channels, one more screen. And this is where you set the scan range. Are you going from 7 megahertz to 8 megahertz or 2 megahertz to 32 megahertz? By the way, this vector network analyzer, this little guy, it only makes 101 measurements. So if you have 10 megahertz, every time you make a measurement there, every measurement is 100 kilohertz apart. And you're dealing with a band that may be 300 kilohertz wide, so you're not going to get very fine resolution. There's a way around that. We'll talk about it. Next screen. Next screen. And then you save them in a memory. And the beauty of this is, you get a brand new piece of coax, you have a brand new antenna, you measure the coax based on the band you want to use it, you can save it to one of those memories, make note on the end of your coax which memory you saved it in. You can come back 3 years later, recall the memory. Your open short load calibration is already done for you, right? Pretty cool. Next screen. And here is where you save. Save 0, 1, 2, 3, 4. So you got 5 of them, 5 different memories that you can use to save those the calibration information, the scan, the type of measurement. Next screen. We're done with that. So in any event, I showed you the models. We did an 80 meter, a 40 meter, a 20 meter, a 17 meter. The 80 meter actually resonates at 3.8 megahertz. For our exercise, I wanted them to run at 3.54. The 40 meter, I told you, is just under 6.9 to 6.89. We want to resonate 7.185, and on down. Next screen. So I showed them, I had us on 80 meter do a scan from 3 to 5 megahertz, on 40 meters 6 to 8, 20 meters 13 to 15, 17 meters we went from 17 to 21. Next screen. And here's what happened. You take that information and you plug it into this other piece of software we're going to take a look at called SimSmith. Now you're trying to figure out how to put a matching network together. We have a name for that. We call them antenna tuners, don't we? That's exactly what it is. An antenna tuner is nothing more than one inductor and one capacitor. And guess what we're going to put together to solve our antenna matching problem? One inductor, one capacitor. We don't know what they are, but by taking our reading of what this antenna looked like at this frequency and plugging it into this piece of software called SimSmith, which by the way is free. Price is right. It told us in the case of the 80 meter antenna, we needed an inductor at 6.5 microhenries and a capacitor of 820 picofarads. There's 2 places for capacitors. And SimSmith tells us which one goes under JP, where the JP2 jumper is or the JP3 jumper. Next screen. I don't want to bore you guys to death. I just kind of want to give you an overview of what this class was about. So here's what a Smith chart looks like. Looks kind of intimidating, doesn't it? Say yes. In any event, if you get a little dot up here on SimSmith, it says that's where your antenna is. It means the antenna is too long. This is a, you guys know what the term nomogram means? It's a method of graphically solving a problem. There's all kinds of them. They make slide rules and stuff that you've seen. They're nomogram. Or if it's too short, you'll get a dot down here. If the dot is right smack dab in the middle right there, that means it's 50 ohms with no reactance. Perfect match. You like that, don't you?
No reactance or is the reactance?
No reaction. No reaction. No net reactance. How's that, sir? Will you buy that? I'm sorry?
I said theoretically or scientifically?
Absolutely.
You choose.
Next. Now you can say, I'm confused. What is that damn graph? It's a nomogram. It's a Smith chart. It's the real Smith chart. So what we're looking at here, you see right there, it says our generator is at 7.2 megahertz. This is SimSmith. And over here, here's our antenna. And I told you we made a measurement at 6.89 or something, right? 6.82. So we plugged those 2 numbers in here. We plugged that number in, the resistance, and that number, the reactance. And then we take this little tiny block and move it up to there. And guess what happens? SimSmith says you need 352.2 picofarads and 3.99 microhenries. And if we can go back a couple. Look at that.
Yep.
It says, yeah, 6.5. 800. I mean, it gave us the answers. We plugged those in and guess what? It worked like a charm. Let's go forward. So anyhow, this is one example. And SimSmith allows you to match this more than one way. Here we used a capacitor and an inductor, right? Have you guys heard of stubs? So, ooh. I didn't say stud, I said stub.
No bragging.
No break. Next screen. So look what I did. I pulled this mess out of there and I put a piece of shorted coax in here, which is this green trace. And I put an open piece of coax in here, which is the purple trace. And guess what? The SWR is now 1.058. No capacitors, no inductors. Solved it on SimSmith in 2 keystrokes. And it works, by the way. I'm sorry.
Which is which? The shorted one is capacitor and the open one is an inductor or what?
The green one is the green one,
Yeah.
and the purple one is the purple one. And an open piece of coax should make you think that could be a capacitor. Right? And guess what? That's what that is. And a shorted piece of coax forms the inductor. Both perform the same function. Okay. Next. I think we went the wrong way. Oh no, this is all right. This is a different one. This one is operating at 18 megahertz. This is 17 meters, right? Oops. What did I do?
Are you able to control it now?
Guess it did. Oh,
Oh,
yeah.
Oh.
Cool.
all right. You're
So
welcome.
anyway, this is our 17 meter antenna. And we plugged this thing in here and it gave us our match. And look what happens. This is where the antenna was. It goes up here, comes back down here. And the SWR now is 1. Perfect match. Pretty good, huh? No pencil, no paper, no slide rule, no headaches. Simple. Move forward, please. James, that's good.
I think you have it.
Yes.
Phil, that one, for the other matching, it would give you the value in microhemorrhage and microfarads. And in this one here, we'll give you some length.
It gives you the length of the coax based upon the velocity factor of the coax
Not what's on the screen. You mean with the stubs?
with the stubs, yes.
Yeah.
This one's going to be a little different. So where am I going? That was, yeah, you can see the stub stuff here. It says 9.806 feet. And it says that the coax property is 50 ohms and it's 0.6667 velocity factor.
Maybe you want to clarify what the velocity factor is.
If you put a radio signal into a piece of coax, and you measure how long it gets to the end of the coax, it doesn't go at the speed of light. It slows down to the transmission line. That's that velocity factor. So it's a timing thing. You have to allow for that. And various coax have various velocities.
Velocity factor
In air,
RF signal does not travel at the speed of light as long as it's going through air.
so how close
Because
is
of the
it?
molecules, it's just, well, it's a point something.
0.99996.
And it varies with- varies with their
Can you come near the microphone and repeat the question?
Oh,
We're working
I'm-
on more microphones for everybody.
we do have a wireless mic. I should have thought about that. In any event, the question was, is there a velocity factor to air? And there is, but it's very close to unity. It's 0.99 something. Okay, did that cover that? Let's go on. Oh, I got to stay over here close to the microphone. So. So this is a 40 meter antenna and it's matched with the LC. Now this is interesting. Has anybody ever heard of a hairpin match?
It's on the test.
Why would you use a hairpin?
Real common match back in the forties and fifties.
Even today. But why would you want a hairpin match?
Because you always got one close spot.
Easy to make?
Well, let's take a quick look.
To get its name, I wonder.
You see this one, I'll show you. This one has a capacitor, and if you got a lot of power, you need an expensive high voltage capacitor of some nominal value, a special value. In this case, it's 207.2 picofarads. You probably won't find that in the catalog, right? We can look, but I don't think we'll find it.
Back in variables.
Close.
You can do that.
Yeah.
You can do that.
200, 300, 400.
But if we go down here and we'll do this hairpin, you see this? You know what that is? That's a couple of turns of wire, bare copper wire. How hard is that to fuck? Not very hard. Is it? And so by using a couple of inductors, you can perform the same match. Look how perfect that match is. 1.009. Is that close enough?
Close enough.
Close enough. So there is a vertical antenna with a loading inductor and a hairpin match.
Looks familiar to me.
Looks familiar. Actually, there's a pair of verticals that are fed this way. So the only thing you have to be careful of, you see how this is routed in one plane and this is routed in the other? If you have both of those coils parallel to one another, guess what you have?
Transformer.
You have a transformer, inductive coupled transformer. That's exactly right. So when you do your hairpins, make sure you do that. Let's move on. So within this NanoVNA, we can also do what's called a time domain reflectometer function. Any idea why you'd want to do that?
Find out how long your answer
There are the
is.
screens on
Cable
the
is?
screen.
I got to stay clear. The reason you'd want to say that somebody, your neighbor who loves you, came by with his hedge trimmer and pruned your coax.
Oh, yeah.
So where is your coax bad? So we use this time domain reflectometer, and I'm going to show you something else here in a second. You see this thing, time domain reflectometry? I had a 13-foot piece of coax, RG58, and I plugged it into this machine, and guess what? They told me my piece of coax was 13 feet, 2.7 inches. That's pretty close, isn't it? So it allows you to find how long that piece of coax is, or if it's open, you'll find out exactly how far down the piece of coax it is where it's open. By the way, you spent $60 on this instrument, by the way. Not a bad deal. Yeah, or neighbors that love you. So anyway, you can see what goes on there. This comes right back up. Now this screen that you're looking at is this other piece of software that I talked about. The piece of software is called NanoVNA Saver. It's free. You plug your NanoVNA into it, and guess what? You can actually read that screen. That NanoVNA display is pretty tiny. So that's a pretty cool function, isn't it? By the way, it's $60 that gives you all this functionality. Oh, and SimSmith comes free. Let's move on. There's a second port. The first stuff we were looking at is all based upon the reflection port. It sends a signal out and it sees what bounces back. That's all antenna analyzers. Most antenna analyzers are only a single port device. But we also have a second port. Why would we need a second port?
Because it'll do more.
Good answer.
Testing filters. Reference point.
Okay.
what we can do with this is we can measure how much loss is in your piece of coax. You put signal in one end, you measure how strong it is coming out the other. That's a pretty good thing to know, isn't it? Or if you got a filter, you know, filters take some stuff out, but there's a price to that. You lose some signal. So if you'd like to see how much signal you lose, this thing will do it. And due to the fact that, you know, you've got that, the input port, the one that does the reflection, you can also see what the input impedance of your filter is. Because believe it or not, filters are designed to work into a specific impedance. If you don't match that impedance, your filter does not work the way it's designed to work. So we can measure that with this. Oops. We can, oops, keep doing that. We can measure that with this vector network analyzer. And I mentioned that you need to match the impedance that you've got that filter plugged into to the system that you're using. Okay. So we did some exercises with that. Where's the right button? Oh, so here is measuring coax loss. Now in this case, this happens to be a 100-foot length of RG8X that I bought down at Pacificon. And if you look right here, this is a chart. I wanted to see what the losses were at 50 megahertz. And that's point number 4. Point number 4 tells me I have a loss of, where is it up here? No. Return loss. No, that's not right. Oh, return, that's not the right one. Return loss is like this. Oh, here it is. S21 D. 4.1 dB loss in that 100-foot piece of RG8X. Okay. So let's see what Belden's, I'm sorry.
50 megahertz.
50 megahertz. So let's see what Belden says. Belden says RG8X. Somewhere up there, 2.1.
2.1.
Yeah, but what does it say RG8X?
Oh.
I guess it's not on this piece of paper. Oh, here it is. Belden, track, blah, blah, blah.
92.
This 9258 Belden. In any event, at 50 megahertz, it says it should be 2.1 dB at 100 feet. Well, 2 dB is 37 watts loss if you start with 100. So far, so good. Guess what we got? Out of 100 watts, we lost 60. So the moral of the story is, do not buy cheap coax at Pacificon.
For that frequency, you might want to go with hard loss.
Not in this particular case. I wanted something small, something easy.
Yeah.
But RG8X, the real stuff.
Yeah, still close.
Well, we're not working at 50
Still close
megahertz,
to
or you know,
40
40 meters. But nonetheless, it's surprising how bad that stuff was. I didn't realize it was that bad. And by the way, the manufacturer that I bought this from, they do not list the losses in their code. So I can't call them a liar.
Or does it say like RG8X?
No, it said RG8X, period.
See a lot of advertisements like RG8X.
So here's the next thing.
Yeah, like my foot.
Filters. So one of our club members is 160 meter buff. And he was talking to me one day and he said, you know, Phil, he said, I do a lot of 160 stuff. And a lot of guys in Southern California I checked. He said, I can hear them fine. They don't hear me very well. No, they hear me well, but I can barely hear them. And I don't know why. And I got to thinking about it. Radio station KFBK, your next door neighbor, broadcasts at 1.53 megahertz.
Adjacent channel would blast those receiver to bits.
And with a power of 50,000 watts. And what's called Franklin antennas, which are halfway for us. They're fed in the middle with kind of an interesting antenna. They have the highest ground wave signal of any radio station in the continental United States. They are very big guns.
Deep Mexico.
They're close to where Bob lives, but they weren't close to where this other guy lives. So we decided we needed a filter. And I built a filter. And the filter's got 1, 2, 3 inductors. And it's got 1, 2, 3 capacitors. Shall we see if it works? The answer is yes.
We know it does. If you did 1530 in there, find out what's happening.
So here we are. Here's 1530. Here's power coming into this thing, and it takes this big old dip. And once you get back up to about 1700 kilohertz, all the power gets through again. This filter reduced that signal by 70 decibels. Again,
You could talk to them.
$60. Okay, let's move it on. So here's an IF filter. Anybody know what that thing is? Anybody else? That's a 2-cent ceramic resonator that you find in every cheap Japanese transistor radio. It's an IF filter. And it's at, can you read that? It's 10.7 megahertz IF frequency. So far, so good. Let's see if it works. Lo and behold, 10.7 is right there. This is stuff that doesn't get through. Here it starts to get through. Kind of a weird pattern. But again, it's a 2-cent part.
I paid 20.
10.7 megahertz. So yeah, it works. It's kind of wishy-washy, but for 2 cents, it works. So let's go to the next slide. You like that circuit? That's pretty cool, isn't it?
You do autograph
Right. This is an IF filter. Again, it's not quite 10.7. This is at 11.058. Bob and I are working on a new project. This is a single conversion, super heterodyne, general purpose receiver, 0 to 30 megahertz. So this is the IF assembly. And again, I want you to note the attention I took putting this together.
Dead bug mount.
I love dead bugs. So anyway, does it work? That doesn't look too bad, does it? So here's 11.058 right there. And at 4, it's 1.978 dB loss at the middle of the band pass. Look at how well it matches 50 ohms. This is an SWR1. That worked pretty good. By the way, there are 8 crystals in that filter. I paid 10 cents a piece for it. So for 80 cents, there's an IF filter that has a bandwidth of 2.4 kilohertz. Try buying one of those from Millicraft. Not bad, huh? So here's another filter. I bought this at a swap meet down in Silicon Valley. I thought that might be kind of an interesting filter. It says it resonates. It's a filter at 42.18 megahertz. And I don't know if it was good or bad, why it was in the junk pile. I just paid the dollar for it or whatever I paid for it. I have no idea. So how's this work? Here is 42.18. And it says here, that's marker number 1. That's 3.2 dB loss in the middle of the band pass. But it's got some weird wiggly wagglies here and some more wiggly wagglies here. But again, for the most part, it's down 70 dB once you get out of the band pass. It works pretty good. I guess it's a good car. Okay, and this is the one. How many of you ever used a grid dip meter? There's some gray hair in it.
Yeah.
Well,
Expensive.
with your NanoVNA, which costs $60, you like that, don't you?
Or for $80, you buy a Porsche.
Yeah, there you go. Well, anyhow, this guy, Wes Hayward, whom I'm sure many of you are familiar with, he wrote an article way back in 1986 about coming up with a more accurate grid dip meter. Because those of you who have used these, when you tune a dip meter, you know, you get close to the coil and you see where it dips and you move it away a little bit more and a little bit more until you just barely get a dip. Because when you get real close, the coil you're measuring pulls the energy away from the oscillator. And so you don't know exactly where it's resonant at. And by the way, let's talk about this magic word, resonance. Could somebody describe resonance?
A point at which maximum RF flows, because you're talking about RF.
There's no resistance, no capacity.
System absorbs the
It's
most
the
energy.
characteristic frequency of the length of whatever.
I'm going to make it simpler for you. It is the point in the frequency spectrum where a system absorbs the most energy. So, for example, your washing machine. You throw a bunch of towels in the washing machine, it goes into the spin cycle, smooth the glass till it gets to a certain point, then it shakes like the dickens until it spins a little faster, and then it dampens down, right? We've all seen that. Or your car tire, you're driving down the road, a weight falls off, and at a certain speed, 37 miles an hour, your car starts shaking like crazy. You take it up to 42, it's smooth again. It's because the car is resonant at that particular frequency, or the washing machine is resonant at that particular frequency. So we can use, and the same is true with a violin string. You're putting energy into the system, but the resonance of that string is that particular frequency. Any other frequency, you can do this with a tuning fork. You got two tuning forks, they're both the same. You beat on one, it's humming. You put the second one next to it, pretty soon it's humming as loud as the other one, right? But if they're different frequencies, you can bang this one, this other one won't do anything, right? It's the property of the system. It's its natural point to absorb the most energy. And you're right about with RF, it's a very easily detectable thing. We use resonance all the time. So this particular thing that we're looking at is a method of measuring resonance, and you've got a source of signal, which is that 0 port on your network analyzer. And then you have a receiving side of it, which is the 1 port, which is the one we do the through measurements with. So we got everything we need. We got a source of energy, and we have a receiver based on that frequency, right? So this thing, all of this is a toroidal transformer with 3 windings on it. And then this is a pickup loop. And this is put signal in here, and you detect the difference between these 2 loops where this detector is. So let's move forward. And this is the article that Wes Hayward wrote back in 1986. And you can see this circuit. Here's this transformer with 3 windings. It's a lousy little toroid that cost you 25 cents or 50 cents or whatever it is.
Plus shipping.
Here are these 2 coils, which are these 2 coils. And that's all there is to it. You put stuff in here and you look at stuff coming out here. So far, so good. So here we go. Here is a coil with a capacitor hung off it. And you note right here, 5.33, that's marker number 1. It says 5.32 megahertz is right there where that marker is. And if you look on this thing, I think it said 5.3 is what I thought that thing was. Works like a charm. But here's the more amazing part of it. You guys know what this is? Yeah, a torque. You ever try to measure the resonance frequency of a torque with a dip meter? You can't do it unless you put a pickup loop through the torque to accept the energy. So I did it with this, and guess what? There is one again, 6.664 megahertz, which is exactly what this thing says. So for nothing, in addition to your $60 vector network analyzer NanoVNA, add another $1 and you got a grid dip meter. Pretty cool stuff, huh? And that, ladies and gentlemen, is the end of my nonsense.
So the grid dip was used back in the,
Well, actually, they did it with tunnel diodes and they did it with FETs and all kinds of stuff. But again, the idea is they're tracking when the energy gets stolen from the oscillator. Somebody, in fact, I have to tell you a real story. Many, many years ago, when Deb and I were first married, we had a cat. So, you know, every day you let the critter in, you let the critter out. The critter's in, the critter's out. So we're out shopping one day and we found one of these pet doors. So I'm happy about this. I come home, I cut a hole in the back door, I put this thing in, teach the cat how to go in and out, which by the way is another task. So everything's fine. Then one evening, about 3 o'clock in the morning, we have a cat fight in the kitchen. We only have one cat.
it works both ways.
So, and by the way, our cat, you know, if one was chasing it, it'd make a beeline for that door. I think the second cat made the same beeline. So the next morning, I'm trying to figure out how am I going to solve this problem? And I got to thinking about the grid dip meter. Because, you know, there's all kinds of ways you can have battery powered transmitters and all sorts of weird crap. And I'm thinking, how can I do this passively? And a thought occurred to me. And what I'll do is I'll take a piece of surgical tubing and I'll wind a few turns of wire inside of this surgical tubing and I'll put a little tiny capacitor across that cord. And then my grid dip meter, I'm going to resonate it to exactly what that cat collar is. I put it together. Lo and behold, worked like a charm. The door latch was a solenoid plunger off an old pinball machine relay. Worked like a charm. So you see, you can take ham radio stuff and solve the world's problems.
Somewhere there's now a pinball machine that only has one way.
No, it's just a plunger. It pulls in and you can push the door past it. Otherwise, well, that's true. That's true. But did you like my cat detector story?
Yeah.
I had a friend with a dog door, a little dog door. And one morning he came downstairs and here in the living room, the dog was come through that door with a dead skunk. Right there in the middle of the living room.
I never built a dead skunk.
Yeah.
I bet your nose would work pretty good for that. All right, that's all I have. Any topics, comments? Yes, sir.
I get 5 minutes of everybody's attention, so.
Step right up.
Come up. Come on up.
Get near the microphone.
Absolutely.
Don't do what I did.
I actually work in technology, so I can't claim ignorance on this. Hi, I'm David, K0DGD. I was actually first licensed in 8th grade, 1978. My Elmer was my industrial arts teacher. He got me hooked. I brought 3 of my friends, actually 4 of my friends, to classes that he was having. 3 of them ended up getting licensed at the same time. That's pretty remarkable for 8th graders when you think about it. Yeah. So throughout my life, I was originally WD0 EIQ. And I let that lapse years ago because I got into technology. I was working in the radio field for a number of years. Went over to IT networking. So I kind of let that expire. My license expired, and probably about 7-8 years ago, I renewed it. So I'm now K0DGD. K6 wasn't available, so I ended up going back to my original home in Minnesota to get to 0.
Minnesota.
Yep.
You have a daughter.
Yes, okay, okay. Right now, I work for County of Sacramento. I'm the system manager for the Sacramento Regional Radio Communication System. And I am fishing for radio technicians. It's a dying field, like us, gray hair people, a lot of you guys here are. I'm looking for people that are willing to learn radio and want a career out of it. If you know people, or you know someone that's interested, that's a ham or wants to be a ham, that's willing to put the effort in, it's a very well-paying job. It's we will train you 100%. We send you away to schooling, and we'll nurture you and develop your career path.
That's a great offer.
Yeah, it is. It absolutely
That's a
is.
deal.
Yes. Yeah. So
How young do you have?
preferably younger me. I'm going to be 60 this year. Most of my crew, I have one opening right now, and I have 2 guys that are probably going to be out within the next year. It's an older shop, so I'm looking for younger guys or fresh blood that are interested. You have to be interested in digital radio systems, Motorola based, so it's P25 based network, Sacramento regional area, so we cover Sacramento County and Davis as well. We have about 18,000 radios on the system right now.
That's a lot of radio.
Yes, yeah, 30 channel system at 10 sites, so 300 plus transmitters to maintain. All network via microwave and fiber optics. So you get a little bit of experience in everything. This is not a bench tech position. This is a system site technician. So you would be maintaining RF sites and doing system upgrades and improvements, measuring. Sometimes we go out and work with BDAs where we do building distribution amps for coverages within buildings. There's some certification that's done on that, or we troubleshoot interference issues from buildings that put amps in and don't tell us and turn them up full blast and cause system interference. So if any of you know anybody that's interested, I'll leave some of my business cards and I'll leave some of the job descriptions too. Please feel free to pass them out, have them call me. I'll coach you through the process to get the application in. It's a little onerous for most people, the questions you have to ask. It's government, what can I say?
Carol, can we put some of his information on our website?
Sure. Yeah, so, and what I'll do is I'll leave my cards, and feel free to call me anytime or shoot me an email. I'm always willing to talk to anybody. If you got a lead or if you know somebody that's interested, send them my way. I'm more than willing to talk to them and see if they're interested and pursue it from there.
Any cat detector needs?
Cat detectors? And I love your story. I have 4 cats. And I have a cat door, and I left it open. And 2 months ago, I had a cat fight in my kitchen as well. So yes.
You have a
So
lot
I'm
of-
going to look at doing
We
good
need a
dip.
pinball machine.
And I used to have that. So yeah, that's an absolutely great idea. Yeah. So if you guys, I'll hang around for a bit. If you guys want to come up and talk to me, ask me questions about stuff, I'll hang out here for a while and see if we can help.
How many people in your department?
I have 10 people working for me, 5 basically techs.
18,000, you said?
Well, what it is we do not support the subscriber radios.
Oh, okay.
We just support the core infrastructure network. So 12 sites and the connectivity around all that.
Okay.
Yeah.
Very nice.
Yeah.
Great story.
Oh, thank you.
By the
Thank
way,
you. Yeah.
I got first license when I was in. What grade would you be when you're 11? 6th, 5th grade. 6th grade.
Oh, you beat me then. Okay.
I did. No, I did.
Well,
Yeah.
he's got you by a couple of years anyway, so.
Okay. Well, yeah, that
That'll
works
do it.
too. Yeah.
That's because I'm a father.
Okay, great. Thank you for your time and your attention. I appreciate it. Yeah.
Yeah.
Who does membership?
Jojo is not here.
Okay, money, member application.
We can pass it.
Okay.
Okay. Okay,
So I have a question, Phil.
what's that?
Those little board antennas, is that a kit thing that's available, or was that something?
That is a Bill Sittner K86RM custom.
Okay, I just wondered because they look like something that somebody would purchase.
No,
They're gonna be in your museum, right?
I was thinking it would be nice to be able to, because we were trying to practice. with-
I've got the CAD files to build more if you're interested. They're not expensive. I think the whole work should be less than $20. I mean, it's,
What to do the whole set.
yeah, because the way it was set up, I had the actual antenna boards. And then I had another set of boards where those little plug-in modules were, but you need a couple little, what am I trying to say? Little, yeah, the.
Oh, the jumper?
header
Yeah, I know what you're
pin.
talking about. Yeah.
Good.
I got an announcement.
Go right ahead. By the way, James wants money for it.
Well, yeah, I know.
How much, James?
Get closer to the microphone.
Get closer to the microphone.
Is this close enough?
Yep.
Right here?
That's good. Thank
That'll
you.
work.
Can I
Yeah.
turn this?
Please.
All right. Okay, I'm Steve, KN6 VDP. I do 70 centimeters simplex tests on Tuesdays over on 145190. And next Tuesday, I'm going to debut the 1.25 meter simplex test if anybody's interested in participating. It's open to everybody. I start the net at 8 o'clock on Tuesday on the 14th,
You did good.
8 p.m.
8 p.m. And then I'll take a list of names of the folks that want to go over and try the 220 simplex. And then we'll QSY to that freak, which is 223.500. And then we'll do some calls and take some signal reports and see how well the 220s work. I know the 70 centimeter works really well. I've got a lot of enthusiasm for that, and I'm hoping to have the same with the 220. So I just wanted to make that aware to everybody. Everybody's invited. So
So
anyway,
question, so we meet on 223 dot,
no, we meet on NHRC, K6IS 145.190.
oh, that's where we have to go first.
Yeah, that's where I start my net. And then I take a list of names, operators that want a QSY over to 223.500, then we do the simplex there. And then afterwards, we come back to 145.190, and then we do our signal reports. you did a similar thing for 6 meters, right? Yeah, we do 6 meters, we do 10, and I do 70, and we do 2 meters. So now we're gonna try the 1.25. So anyway,
1.2 gig.
everybody's invited if you have like 220 gear.
You know, you can buy a NanoVNA that goes to 3 gigs too.
Or you can buy a Baofeng triple for $26. I just programmed one today. It works great. So
Enjoy.
Thanks, Steve.
yeah, thanks.
Okay, anything else before we send everybody home? Now, do you have a kitty back there for those of us that wish to donate to the refreshment fund?
Yes, I do.
Okay, I'll be back to see you because I have a quick answer. Thank you, everybody. By the way, thank these two for putting on our production.
Yeah.
That's great. Thank you, guys.
Kudos.
Fine work.
Out of that stuff for a long time, but I saw these guys.
Well, whoever stays long enough to do against them, I guess.
Yeah.
Yeah.